Good morning, students. Today we have our first lab, theoretical lab for Organic 2. Today specifically we are going to perform a purification of benzaldehyde. This is the biography that you may take to study for the quizzes and to go if you have any doubt regarding the experiment itself or the theory behind the experiment. You can also ask me, right? So let's begin. The benzaldehyde is most known as benzaldehyde itself, but it can be also known as benzene carbohaldehyde, which molecular formula is this one that you can see here. You can also check the molecular weight, and the appearance is colorless liquid at 23 degrees Celsius and 1 atmosphere in pressure. It smells to almond-like, and you can also see other physical properties like density, boiling point, and the mixability of water. In that form is not mixable of water in water. So what happened? Why the purification of benzaldehyde is as important? Because most aldehydes are easily oxidized by atmospheric oxygen to carboxylic acid. This is called autooxidation. So as you can see here, two molecules of benzaldehyde can react easily with oxygen and get as a product benzoic acid. So that's why benzoic acid is a very common impurity in benzaldehyde. That's why, as consequence, it's very important to know how to purify this specific compound. So, the mechanism for autooxidation of benzaldehyde is as follows. So, first is the proposed is formation of peroxybenzoic acid. What happened? That benzaldehyde, this bond that we can see over here, this bond over here is broken by homolysis, right? And as a result, we get two radicals. This radical and the other radical of hydrogen, right? And at the same time, oxygen, one of the double bonds, the pi bonds of the oxygen, uh, is broken again by homolysis, and we get a biradical, that is oxygen in this case. So this is the product as intermediate, which is peroxybenzoic acid, and thus after that happen what is the Baeyer-Villiger oxidation. So in this case, the peroxybenzoic acid gets the rupture of this bond by heterolysis, right? As a consequence, we get an anion in here and a proton, which is this one, right? Another molecule of benzaldehyde, which is a nucleophilic molecule, it means that it has an electronic cloud that is very rich in electrons, so it's looking for nucleus. In this case, the non-bonding electrons of the oxygen atom are going to attack the nucleus of the proton, or the proton itself, and as a consequence, it's going to build this bond, and as a result, the oxygen is going to get deficient in electrons, right? That's why it has a positive charge. And simultaneously, then this this bond, these two electrons that are in p orbital in this double bond are going to replace the non-bonding electrons that were missing in the oxygen. It is going to occupy non-bonding orbitals, right? And this anion is going to attack this carbon that at this moment is going to be deficient of electron. Also, it's going to have, if it was a sequential mechanism, it could have a positive charge. But in this case, since it is simultaneously, this anion is going to supply the deficiency of electrons of this carbon itself, right? So, as consequence, we have this intermediate in here that is going to accommodate easily with, in this case, these two electrons are going to occupy the pi orbital of the bond oxygen carbon, and these two electrons as well are going to move to the electronic cloud of this other molecule right here, and we are gonna get an anion here and a cation, which is going to be the proton. Consequently, this anion is going to attack the proton, these two electrons, and build the two molecules of benzoic acid, as you can see here. This is the mechanism in which we have the benzaldehyde, how it oxidizes to benzoic acid, right? So, how do we purify the benzaldehyde? By washing the impurities of benzaldehyde with an aqueous solution of carbonate, sodium carbonate solution, right? As you can see here, sodium carbonate is a base that will react with the benzoic acid, which is the impurity of benzaldehyde, right? How it happened? First, we have the water that plays a crucial role here in order to break this bond of oxygen hydrogen, and then as a consequence, this oxygen that is nucleophilic is going to be more attracted to this sodium cation, which is more electrophilic than this proton, and then this oxygen is going to occupy to join with the carbonate in the solution, right? Then what we're gonna have is this salt, which is named sodium benzoate, and this other salt, which is sodium bicarbonate, right? And then sodium benzoate, as you can see here in this statement, sodium benzoate is a salt and it's a very polar molecule because it's a salt, has very dipole, very polar or very high dipole moment. As a consequence, is very soluble in water, right? Then benzaldehyde is relatively non-polar molecule, so it's not soluble in water. So how can we remove it? By simpler water extraction, by filtrating. The solid, what we have in the filter paper as a solid, is going to be the pure benzaldehyde, and then what remains in the solution after we filtrate, this is going to be the impurity, the benzoic acid, or as a salt. So the lab procedure is as follows. First, we have to prepare a 10% weight sodium carbonate solution, and you must get ideally around 50 milliliters, right? Then we have to take 5 milliliters impure benzaldehyde in a separatory funnel. Wash with 5 milliliters of the solution of sodium carbonate that you have. Then This is an aclaratory note which say that do not go crazy while shaking the funnel, right? You have to shake, but um, you have to be under control of what you are doing, right? Otherwise, it will make an emulsion, right? Don't do it as fast. That's that fast. The step number 4 is to separate the aqueous layer, which is the bottom layer, right? Uh, Repeat the procedure step to 4 one more time. This is to make sure that everything is going to be extracted, right? Wash with 5 milliliter water. Separate the aqueous layer. Then collect the benzaldehyde in a flask. Dry over anhydrous magnesium sulfate and collect the dry benzaldehyde by gravity filtration. So that's the way to do it. Again, you get a solution, an aqueous solution, in which you are going to dissolve the to mix the benzaldehyde, right? Then you have to mix at 5 milliliter of aqueous solution of sodium carbonate 10% in weight, and shake. Then remove the aqueous phase of the funnel, which is the one that is in the bottom. Repeat this step 2 more times, and then we have to filtrate the remaining solution, right? To collect the benzaldehyde. First, before we have to dry over anhydrous magnesium sulfate. That's very important to remove the small pieces of amount of water that we have in that solution, right? So to have the organic phase purely um, out of water, right? And after that, we filtrate. Okay, as you can see here, we need to 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 make a filter paper by doing these steps or to the circular filter paper, right? There, in order to storage the pure benzaldehyde, we have to add small crystals of hydroquinone to the pure benzaldehyde and cover it with paraffin, right? This is because the hydroquinone reacts faster or readily with oxygen than benzaldehyde. So if any oxygen get in the flask, we'll prefer or to react or to oxidize hydroquinone to benzoquinone rather than benzaldehyde to benzoic acid, right? This is the mechanism you can easily, or the reaction that you can easily see. And so that's the main um, uh, purpose of this experiment, right? We already purified, we already dried, and storage the benzaldehyde, right? So the waste must be disposed as follow, right? The magnesium sulfate is going to go to the solid waste. The aqueous waste, which is the aqueous portion from the separatory funnel, is going to the aqueous waste. And of course, you need to clean your hood before leaving, right? So again, before we finish, we get the solution, an organic solution of benzaldehyde, right? Then we mix it with an aqueous solution that contains sodium carbonate. We shake it. We remove the aqueous phase of the or portion of the in the funnel. We keep the organic phase. Then we do this step 2 or 3 times. Then we add um, magnesium. We dry this organic phase over anhydrous magnesium sulfate, and then we have to collect the dry benzaldehyde by gravity filtration. That's this step. We have suspension of the benzaldehyde, and we have to filtrate to collect the the dry benzaldehyde by filtration. That's it. Finally, we have to add small amounts of hydroquinone. So I hope you understood all the procedure, and if you need any help or don't understand something, you can let us know. As always, you can write me uh, through my email, and we can talk, or I can help you in any case, right? I hope you have a great week, and see you soon. Bye bye.